My name is Pradeep Bhanot. I do product marketing at Actian, and I specialize in our analytics portfolio of products. Our mission, for the people who aren't familiar with Actian, is we're a database provider and data integration solution provider. We provide data management and integration technology for hybrid environments running on-premise and in multiple clouds. So we have something like more than 3,000 customers, 350 employees. We have very satisfied customers with a satisfaction rating of more than 95%. We hold 53 patents, and the ones we're most proud of are performance related. We're proud to have the most performant analytic engine on the planet, and I'll be telling you more about that in a second. 24 of the Fortune 100 use our solutions, and you can see some of their logos below. On the next slide, I'll drill down into some of them. So in terms of integration technology, one of our leading customers is ADP, running payroll for more than 125 million subscribers across the US. In the UK, the AA is a big user of Actian's database technology. One of the most interesting customers in the UK is Oxford University. So every time you go to a GP and they do a test on you, that data is anonymized and sent to the Oxford University Clinical Trials Unit. And all that clinical trial data is collected in an OLTP database, which is based on Actian's Ingress database, which is has evolved to a thing called Actian X, which is a hybrid OLTP and analytics database. So what Oxford does is store all the clinical trial data in the row-based OLTP database, and then when they want to analyze that data, instead of creating traditional indexes, they just create vectorized columns in using the columnar engine. And what they do is sell that research data to organizations doing research around the planet to basically look at causes of disease, etc. So that's one of the cool cases. The Irish Revenue use Actian to manage all the data they collect on taxpayers, including imports and exports. So if they can't clear customs, it's due to us. In terms of the next generation of needs for analytic applications, the things we're seeing in the market are increasing hyper-personalization. People want to see demographic data, social media data, web traffic data, that all needs to be consolidated and analyzed so people can make better decisions. And they basically need a database that can handle multiple streams of data in real time and provide fresh information on that data. The most common use case for the use of that information is customer management, quality of service delivery. And in terms of infrastructure, we're seeing an increasing number of data being collected at the edge of a network. So information from sensors, social media, etc. And we have an embedded database technology for collecting some of that. We're seeing cloud as the biggest movement in the database market. Every organization has a plan to take advantage of the cloud, because cloud economics are pretty compelling. And it used to be that security was one reason people didn't want to go to the cloud, but now the security provided by the cloud platform is actually superior to many of the features provided by on-premise solutions. So our solutions are SOC Type 1 certified, and our cloud platform has been in use for many of our technologies for a number of years now. So in terms of visualizing that, what we're seeing is that data is coming in from all over an organization, from the edge of the network. That data needs to be aggregated and filtered before it gets to the core systems. And having a very compact database with a small footprint, but maybe 2 megabytes, that can be used using SQL or NoSQL, just key and data information, and having a portable file format that can go to a gateway that can do aggregation and filtration of that stream data from sensors is very useful. And then centralized databases used to be running inside a data center, but increasingly they're running in the cloud. According to Gartner, if you look at the Fortune 1000, they can't just move to the cloud overnight. It's a very big operation for them, and typically only 21% of large organizations' data is in the cloud today. So nearly 80% is still on-premise. So there's a real need for solutions that provide the compatibility between the cloud and on-premise and allow them to interoperate. So the world of multi-cloud and hybrid is here today, and hybrid is the fastest mover in that space. And in terms of the other sort of hybrid is what I mentioned with Oxford University, is the idea of a database that is multi-mode. It can handle OLTP, row-based data, as well as columnar analytic workloads in the same database. The reason you want to do that is to minimize data movement between databases. So if you can consolidate your data warehouse and your operational database into a single solution, that's something very useful for a lot of applications. So if you've got a data mart supporting an OLTP application, if they could both run in the same database, you don't have to do any. You can basically get fresh information from the OLTP operation almost immediately using a columnar approach. So let's talk about how databases have evolved over the years. I've been working with databases since the mid-80s with SQL DS, then DB2, 13 years at Oracle. And what Actian has is by far the most efficient database engine I've ever seen. And I'll explain why that is in a couple of slides. But basically where databases started were on-premise, on large boxes, mainly monolithic applications. So I used to use databases like vSAM, IDMS, then SQL, then DB2. But over time, those evolved to more of an appliance approach. So the large appliances first, like with British Airways, they used to use a lot of Teradata boxes. Like their machine room for Teradata is bigger than this hall. I was amazed how much they had. So that's your traditional appliance model. And then over time, those appliances became more commoditized, and companies like Netezza appeared, Mako, and a modern appliance would be Exadata. Exadata is an appliance as well as Exasol. But the problem with those appliance approaches is that when it comes to time to expand those boxes, you have to buy a whole new box typically, and you have to provision it. It's just not as flexible as a cloud approach. So the cloud came along, and organizations like Amazon with Redshift created the first generation of cloud databases. We actually acquired a company called PowerXL, which had a technology that came from a company called, and we also had acquired a company called VectorWise, and they both were columnar parallel technologies. So the first generation was based, and PowerXL licensed their technology to Amazon, and that became Redshift. So Redshift is still the most dominant cloud database out there. The downside with the Redshift approach is Amazon provides a lot of capability and tools in their cloud, but every organization has to be their own systems integrator. It's not very well managed. You still have to you have to manage your Redshift instance down to the node level. So it's not very it's not what you'd call a managed solution. And the other big downside of Redshift is you can't turn it off. Amazon's in the business of selling CPU and storage, and that's something you have to live with. Still, it's a good technology. But that was really eclipsed, I think, over the years when Snowflake came along with their more managed service. It's much friendlier than Redshift. It's flexible, and then you can turn it on and off. So that's a big plus. But it has limitations. So that's why we think the third generation is the answer. It gives you the best of both worlds. It gives you the power of Redshift and the flexibility and the friendliness and the managed service that Snowflake provides. So basically, with Avalanche, our cloud data warehouse, we give you the ability to turn off the compute, which is the bulk of the cost, and give you the ability to hide all the complexity. The real benefit of a managed cloud data warehouse is that you get to hide the complexity of trying to do it yourself. So the on-premise version of Avalanche is Actian Vector, the unmanaged version. And the problem with that product is that you have to know Hadoop. It's really hard to find Hadoop skills these days. And that's the kind of complexity that Avalanche hides. It takes care of the security, the patching, and the need for IT to help you. So, and performance is a big reason you go with Avalanche. And I'll tell you more about that. So what is Avalanche? It's basically a cloud-based managed service. It's high performance. It's an operational data warehouse. What we mean by operational is you can give it operational information in near real time, and so you can operate your business in near real time. It's not like a traditional data warehouse where you can only update it overnight, like an OLAP cube, for example. You can stream it data almost immediately, and you can make business decisions based on that data. One good example of real-time data, there's a company I work with in the south of France called Expandium. And Expandium have an Actian database for analytics supporting a telco use case. And that telco use case, they have something like this French telecom operator, mobile operator, has 20 million customers. Those 20 million customers make 5 billion calls or text messages a day. And those are fed into the database at 5-second intervals, so micro batches. And they need to see the quality of the service on their dashboard on a map in real time. So when they have an outage or any kind of service problem, they visually see it, and they need to be able to drill down to the individual drop call. No other database can do that. So that's like the big advantage of having a highly scalable database that can handle updates in real time. Avalanche is provided as a cloud service, so you can access it from anywhere, and it uses a pay-as-you-go model, like any great cloud service. In terms of getting going, it's really simple as 1, 2, 3. You create your cluster. I'll walk you through that. You load your data and connect all your existing tools, whether they're tools for getting data into the database or tools for getting data out. Whatever you currently use, Click, Looker, Tableau, etc., will all work with Avalanche. Okay, so let me talk about the architecture a little bit. So we designed Avalanche to support all your business users, your analysts, your data scientists, as well as your data engineers. It uses standard APIs like ODBC and JDBC, and this is the core differentiator for Avalanche. It does a lot of things well, but the thing it does best is process a lot of data quickly. So imagine it's a columnar database, so each column has the same data type. It takes advantage of vectorized processing. So the data is in memory, but we optimize it to be on L1 and L2 cache on chip. And we only decompress it when we're going to process it. And the Intel built into every 64-bit processor a set of high-performance computing instructions for vector processing, and we take advantage of that. What that means for you is that in one CPU instruction, we can basically load up every core in every machine in that cluster, and we basically fill all those registers, and in one CPU instruction, process all that data. That could be 1,000 elements without doing any context switches. That's what makes it the fastest database, in case anyone asks. So I won't go into the other details in this 20-minute session. But in terms of file systems, we use HDFS if you're running it on-premise or in the cloud. If you're on Azure, we use ADLS. On AWS, we use a pretty fast storage mechanism called EBS. EBS is spinning disks, but they're front-ended by SSDs, so they're very fast. That's what makes Avalanche scale in the cloud on AWS and on Azure. And in terms of accessing data outside the database, we can actually create an external table on S3 or ADLS, define it in the database using Spark data types, and then we can access that just like it's an internal table. So you can do create table natively inside the database as select star from an external table, and you only want like 2017 data. So if the external data source is an S3 bucket with 1,000 CSV files, we'll push that predicate down into that external data source and only extract the data for that 1 year. So it's very efficient. In terms of platforms, it runs anywhere on AWS, Azure. GCP is coming next year, and you can download it and running locally in your own VMware environment or Linux or even Windows. And the other cool reason to use Actian is that we have a lot of integration technology. We have 200 out-of-the-box connectors to Salesforce.com, Workday, etc. That works straight away, so you don't have to go to a third party for that. In terms of application modernization, the top half of the slide shows the traditional EDW, where you have a centralized data warehouse and all the tools surrounding it. We think the world's moving towards a more distributed model, where you'll have data on-premise or in the cloud or across multiple clouds, and you need the ability to register tables in those remote locations inside one database and have a single query that can span multiple data locations. One could be Azure, one could be on AWS, one could be on AWS, the other one could be on-premise. So basically you want to be able to do distributed joins across multiple locations. And in terms of moving to the cloud, like I said at the beginning, not every organization is ready to move 100% to the cloud today. So if you want to take your time on your cloud journey, we basically give you the ability to move at the pace that suits you. Keep the data on-premise that suits you today, and move to the cloud or multi-clouds as it suits you. Most organizations, they'll have data lakes or data puddles across different clouds. S3 is really cheap, so a lot of people are putting the data marts there. And our philosophy is basically we can put the compute wherever your data is and give you the ability to take advantage of it wherever it lies. Okay, so filling in that diagram I showed you earlier with some of the products that are involved. So at the edge, we have an embedded database based on old Btrieve technology, which has a footprint of 2 megabytes, and it runs on iOS, on Android, Raspberry Pi, etc. But the cool thing about it is the same file format you run on those devices can be run on the gateway device. So there's no ETL to do, no file translation to do, and you can do your aggregation and filtering on that gateway device before you send it up to the cloud or on your on-premise data warehouse. And if you really want to get fancy, HTAP is what Forrester calls it, and I think Gartner has their own term for a hybrid database. But basically, you can take advantage of the ability to have a hybrid of row-based processing as well as columnar data processing in a single database, and the whole thing can be connected really easily. So getting started with Avalanche is as easy as name your cluster, decide where you want to put it, typically wherever your data is. North Virginia in this case, choose the size of the cluster you want, like eight AU's Avalanche units, that's 0.5 terabyte per Avalanche unit compressed. Choose the IP addresses that can access that service. And once it's there, it's very secure because only whitelisted IP addresses can access it. Data can be controlled in whether it can be encrypted in motion and at rest. It will work with authentication from Kerberos and LDAP, and has a lot of controls inside the database for granting access to different users or groups. We can mask data. If it's sensitive data like credit card numbers, you can mask the leading parts of it, and so it's a very secure place to keep your data. And whatever data tools you have to get data into it, I've seen Attunity here, HVR, Talent, Kafka, Confluence, etc. All of those can be streamed into Avalanche. And to get data out, your favorite BI tools, Looker, Power BI, etc., all work with it. And I saw Data Robot here as well. We actually resell HVR. HVR is a great tool for CDC. So if you ever need to capture data from logs and distribute it across multiple databases, that's a great tool for doing that. Connecting to the database is easy. We give you the connect strings. In this example, I'm whitelisting a particular service from Looker. I look at the dialog for Looker, get the connect string for that, run your queries inside the line mode tool, or you can create dashboards. An example of a dashboard, running Looker against Avalanche, another database. In this example, both databases start off with 52 million rows. They're both doing the top of the page is Avalanche, the bottom of the page is another cloud database. And as the application runs, you'll see new insights about products being sold in a certain state. We do a market basket analysis, which is fairly complex, and we're loading data at the same time. Avalanche loads data faster. At the end of the demo, if you'd like to see it at the booth, we've loaded 40% more data, got multiple insights which you wouldn't have got, and basically serviced more queries and more concurrent users than any other cloud database. So anyway, that's the end of the presentation. If you have questions, you can ask them now or come to the booth.